Indiana University East School of Natural Sciences and Mathematics, calculating wavelengths in the hydrogen spectrum. So for the hydrogen atom, we've seen before that this equation gives you the energy of each energy level. Okay. So n equals to 1, 2, n equals to 3, say. This is not to scale. And so there's an energy gap, say, between energy level n equals to 3 going to n equals 2. There's an energy change, okay? Delta E. When you go from n equals to 3 to n equals to 2, say, and the energy difference is given by, therefore, delta E is equal to minus 2.18 times 10 to the minus 18 joules times 1 over nf squared minus 1 over ni squared. Okay, and from this, and this would give you a negative number if a photon is emitted. Okay, so here n equals to 3 going to n equals 2 will lead to emission. Of course, I found I made a mistake earlier. Leads to emission, and from this, the absolute value is given by hc over lambda. Would be related to wavelength by hc over lambda. The best way to go through this is by an example. So let's go for the example going from n equals to 3 going to the n equals to 2 energy level in the hydrogen spectrum. Note that this doesn't work if it is not the hydrogen atom. So delta E here is equal to minus 2.18 times 10 to the minus 18 joules times 1 over ni squared, and this is equal to minus 2.18 times 10 to the minus 18 joules, and then my nf, my final state, is 2, so that's 2 squared minus 1 over ni, so that's 3 squared, and that comes out of minus 3.03 times 10 to the minus 19 joules. Note that it is negative here because you're going from a high energy level to a low energy level, so the atom loses energy, so that's negative. And as this energy is emitted in the form of a photon, the photon therefore has this energy. As a result, the absolute value of this energy, which is 3.03 times 10 to the minus 19 joules, is equal to hc over lambda. I can rearrange this equation so that lambda is equal to hc over the absolute value of this energy. H is Planck's constant, 6.626 times 10 to the minus 34 joule seconds. C is the speed of light, which is 2.998 times 10 to the 8 meters per second, divided by 3.03 times 10 to the minus 19 joules. And so this gives me a value of 6.56 times 10 to the minus 7 meters, which is 656 nanometers.